Hello there, Algebra IIB, and welcome to Lesson 8.4. Today we're talking about logarithms, a brand new topic for you. And what they are, we're going to come to find, is they are the inverse of exponential functions. So first off, what is a logarithm? And let's just dive on in. So this is what a logarithm is. X is equal to the log base b, and we'll say to the y, okay? That is what's going on here. We have some number x is equal to log. We refer to this number here as the base of the logarithm. Literally, these letters, log, are represented. And the main idea today is we are going to be looking at how these relate, so rewriting them as exponents. A little note that most of the time we're going to refer to the common logarithm, not always, and the common log is always base 10. So that's the common logarithm, okay? The relationship between logarithm and exponents, this is going to be very important to write down and kind of see what's going on. If we have the log of base b equal to y, or log base b of y is equal to x, okay? Log base b of y is equal to x. We can rewrite that as b to the x, the base to the x equals y. That is the key. So I think some colors can be helpful. We'll use blue for the base, red for the x, and y will be green. Basically, what's being asked here is what power, so b to what power equals y. That is what's going on here. So that is our relationship today. So rewriting each equation in exponential form. If we look at this one here, 13, 169 equals 2. How we rewrite this? Okay, let's do some highlighting here. 13, that's our base. So 13, our x is 2, so squared, and then equals y, 169, and that is true. You'll find 13 squared equals 169. Okay, so getting you used to this today. It's a little funky. We're switching around, left, right, all that. So I encourage you, use a highlighter. Number 2, okay, and it'll get pretty quick. So that little base of 5, that becomes 5 to the what? Well, it's going to be 5 to the 4th, and that equals 625. So that is the idea. Don't be afraid to see things like variables. Okay, so same process. 11 to the x equals 191. We'll be solving these in the future. Today, we are just rewriting. So again, 191, 11 is the base, and x is the exponent. Okay? If you want to pause and try out number 4, all variables, but again, b is our base. So we're looking at y to the z, it's a little backwards, equals x. Okay, so a little funky, but just follow that process. Try and memorize this. You'll have this relationship for you for the time being. Now, you can also go backwards. So rewriting as a logarithm. So it could be helpful if we just remember we're looking for log base b of y equals x. So just going backwards, again, let's highlight. So what we know is 2 is going to be the x. The big number, 64, is going to be the y. And 8 is going to be the base. So if we had to rewrite this, it would be 8, log of 8, It should be a little 8, of 64 equals 2. So that is rewritten there. Let's look at number 7. We got a fraction. It'll be the same idea. So log, okay, of y, because that's our base, of 131 over 141 is equal to x. Okay, so again, you can highlight things. X is going to be what it's equal to. The bigger number, or what we're equal to here, 131, is going to be this part here. And the base is always that. Okay, so a little bit different. Again, I encourage you, highlight. Highlight if you need to. 19 is our base. 2 is our exponent. 361. So if we had to rewrite that, whoops, it's going to be log base 19 of 361 equals 19. Okay, once again, pause if you need to. Try out number 8. I'll take care of it here. And that is the answer. So going backwards, rewriting, that's the one challenge for today. Evaluate each expression using your graphing calculator. There's a few ways to think about doing this, and I'll show you 2 of them here essentially. One, you could rewrite them, or I'll show you how to use the calculator. So remember, log 2 of 164, if we're essentially solving this, what we're looking at is 2 to what power equals 64. And this might help. 2 to what power equals 64. So that's a question for you. There's also a way to do this in the calculator. With your graphing calculators, and it is important you have a graphing calculator for this, we are going to go under Math, okay, and we're going to scroll on down and do log base, okay. So we are going to do log base, and here we'll be able to fill it in. So we have 2. And we're going to do 1 over 64. Sorry, that should be a 1 over 64. 1 divided by 64. Okay, you hit enter, and you're going to get -6. So essentially, 2 to the -6 is equal to 1 over 64. The main answer is -6. Okay, so let's try that again. 6. This might be easier. You're again thinking 6 to what power is 36? And you might be thinking, well, squared. But let's do this in the calculator. So, Math, you're going to scroll down in num till you find log base. It's A. And you're going to put in the 6 and the 36, and it should be 2, yeah. Because 6 squared, that's what you're finding, equals 36. So we're finding an exponent. So 2 is the answer there. Once more, 10 and 11, or 10 and 12, log 7 of 49. Again, you might be thinking 7x equals 49. So you might be able to think, okay, well, that's 7 squared. So 7 squared equals 49, which means we are looking at x equals 2, essentially, for our answer. Once more time, if you need to use your calculator, Math, down to log base, and you can do 7 and 49. Sometimes you will get decimals, but you'll be okay. Try out 12, pause the video, and again, you should get a regular number. You can also think 5 to what power is equal to 1 over 25. Now be careful. When in doubt, calculator out. So let's do log base 5, 1 divided by 25, and you're going to get negative 2. So x equals negative 2 with that one. That's the main idea, guys. Rewriting, using your calculator. Welcome to the world of logarithms. And try out those practice problems. Really should be pretty easy. Rewriting